what we're talking about here are the sum and difference identities for sine and cosine. And these formulas you're going to have to memorize, okay? So maybe not for a quiz, which we'll probably have next week, but for a test. And they're important to memorize because kind of when you get to calculus, I know I've taught it before, but they expect you to know these formulas pretty well, okay? Because they come up and you have to take derivatives of things that involve these.
Do they expect us to know them like you expect us to know the Pythagorean theorem?
Yeah, kind of like that, okay? So cosine A, it's kind of rhythmic, if you will. So cosine A plus B is equal to cosine A, cosine B, minus sine A, sine B, okay? Cosine A minus B, the sign is in between the two is actually the opposite of what you would think it is. So cosine A minus B, they call it alpha and beta, but it's cosine A, cosine B, plus sine A, sine B, okay? With sine, the way to remember it is that the plus sign is the same, and it goes sine, cosine, cosine, sine. So this goes sine, cosine, cosine, sine. This goes cosine, cosine, sine, sine, okay?
Yeah, because,
and I'm not sure why. It just works out.
Plus and minus thing because sine is even or odd, or sine is
I
wrong, cosine is even.
don't know.
Is that why like the sine is?
I don't think so.
Oh.
Okay, so sine of A minus B is equal to sine A cosine B minus cosine A sine B. So when you're doing your homework, you could just kind of remember these things. Oh, I didn't start record. Oh, I did start. Okay, and then you have to use them. Okay, so what these are used for is finding angles that are the sum or difference of two angles. For instance, and you can find the exact value of them. For instance, the cosine of 75, okay, which we'll draw like over here somewhere. We don't know the exact value of cosine 75 because it's not a point on our unit circle, okay? However, you can use these formulas to figure out the exact value of the cosine of 75 because I know two angles, which I know that cosine or sine of, that add up to 75. What are those? Nice, okay? So I can write the cosine of 75 as the cosine of 45 plus 30, or 30 plus 45, it doesn't matter, okay? And we're in degrees here, okay? And then you just plug into the formula and you try to simplify that. So the cosine of 45 can be written as cosine 45 cosine 30 minus sine 45 sine 30. So you just plug those numbers into the formulas, okay? And then you use your unit circle to find these things. Cosine of 45, anyone know what that is? Root of 2 over 2, okay? So that's root of 2 over 2. Cosine of 30 is root of 3 over 2 minus sine of 45, which is also root of 2 over 2. Times sine of 30, which is 1/2. And then you simplify this, okay? So root of 2 times root of 3 is root of 6 over 2 minus root of 2 times 1 is just root of 2. I'm sorry, that should be 4 on the bottom. So you multiply the denominator to get 4. And root of 2 times 1 is root of 2, and 2 times 2 is 4. And then I could write the entire thing over a common denominator. You cannot add square roots, okay? You can multiply them, but you can't add them. So that's how you write your answer. Root of 6 minus root of 2 over 4. So the cosine of 75 is the root of 6 minus root of 2 over 4. Exactly. Okay?
That's actually not too bad.
That's not too bad, right? It's just plugging in the formula.
Memorize that.
Yeah, you just have to know the inner circle. The hard, and I could have done this like, you can, it's not just, you couldn't just have used these two angles. I could have used like, I don't know, 100 and, why would you want to? But I could have used 135 minus 60. right? I could have gone 135 minus 60, and I could have used this formula right there, right? So it's not just, there's not one correct way, but you should get the same answer if you simplify it. Yes, sir.
Are you ever gonna give us an angle that we cannot like?
That you
add or
can't do that?
subtract? Yeah.
No, no. Okay? So then, yes. So the next one, let's see. So for this one, place, capture, new page, partial. There we go. Find the exact. So this one here is a little bit trickier because it's written in terms of pi. So what I would do is try to think of this. Pi over 12 is half of pi over 6, right? You know what pi over 6 is? What's pi over 6? 30 degrees. So if you want to, you can change everything into degrees, okay? Because that's 15 degrees. So how can I get 15 degrees?
45 minus 30.
Right, that'd be 45 degrees minus 15 degrees, right? No, minus 30 degrees, which both you know the sines and cosine of. Or you can kind of be clever and know that this is equal to the cosine of 4 pi over 12, which is the same as 4 pi over 12 is the same as pi over 3, which is 60 degrees. No, that's wrong.
Wait, where'd you get 4 pi?
Why wouldn't we just plug it into the equation? We already had it. Where did that just?
Yeah.
Pi over 12, just chill. Either way, doesn't matter, okay? So 3 pi over 12 minus 2 pi over 12 would give you pi over 12, right? And that reduces to pi over 4, right? And that reduces to pi over 6. Because it's good to think about in terms of pi, that's why. Okay? Because it's kind of like learning a new language. So let's just do it in terms of pi. Because you are supposed to try to think in terms of pi. So we have cosine of pi over 4. This is the cosine subtraction formula. Now, cosine pi over 6. This is a what sign in between the two? Plus or minus? Plus. And sine pi over 4, sine pi over 6. So that's the way you set up that one. Pi over 4 is 45 degrees, pi over 6 is 30 degrees. So cosine of pi over 4 is root of 2 over 2. Cosine of pi over 6 is root of 3 over 2 plus,
Slow down a little bit.
Yeah, hold on.
I'm just getting these things out the unit circle. Sine of pi over 4 is root of 2 over 2, and sine of pi over 6 is 1. So simplifying
Can you
this.
just go? Can you go slow, please?
No, because I gotta get through this, okay? Plus root of 2 over 4, and I get root of 6 plus root of 2
Wait,
over 4.
Wait.
so root of 2 comes out.
All right, we're moving on now, okay? All right, use the sum and the differences to prove that this is true. Let's do this one over here. I'm not going to do both of them. Find the exact value of sinus 7 pi over 12. Let's do that. Okay, so with this one, what we're going to do is an identity problem. And this is proving that this is true. And this isn't as bad as you think it might be, but when it comes to tests, everyone has a hard time with it. So let's watch what I do here. I'm going to use the sine subtraction formula, which is sine alpha cosine beta minus cosine alpha sine beta. Okay, so this is alpha here, this is beta. Right? So this would translate to sine of pi over 2 cosine of beta minus cosine pi over 2 sine beta. Got it?
Wait, are you using different identity?
Yeah, this one is sine A minus B, which is sine cosine minus cosine sine. We got it? Can you have a formula for that?
Where's
do.
that formula
It's
come
right
from?
there. Sine alpha minus beta, sine alpha cosine beta. It's right there. That's the formula I'm using.
Wait, which problem is this?
It's this problem.
Alright.
Okay, so going back. There we go. I'm going to finish this. What is the sine of pi over 2? Please tell me you know what that is. 1. And then you just leave this as cosine theta. Okay? And this is cosine of pi over 2 is what? 0. And you get 0 times sine of theta. And since 0 times anything is 0, this goes away. And you get that this side is just equal to 1 times cosine theta, which is plain old cosine theta, which is where I was trying to get to. Okay? And that's how you do that. It's not very hard, but people always, they don't know what to do when it comes to quiz or test. And because you don't, I don't know, people don't.
Wait, can you get that up there for a second?
Sure.
It's 11/11. Make a wish.
It's 11/11, make wish. That's 11/11/2000. Okay, so I'm not going to do this one here because I did one just like this, okay? This one is one that people get wrong, and what you have to do is recognize this as, okay? This is, watch how you do this one here, okay? This looks like the sine formula for subtraction. So this is actually sine of 80 minus 20. Do you see that?
Yeah.
Because this is the sine formula. This is sine, or this is alpha, this is beta, this is alpha, this is beta. So it's sine alpha, cosine beta, sine, cosine alpha, sine beta. And so here, this is equivalent to sine 80 minus 20, and what's 80 minus 20? 60. So it's just sine of 60 degrees, which you should know is
5 over 3. 3 over 2.
root of 3 over 2. Okay? Root of 3 over 2. Okay? So that's how you do this one. This one you just kind of have to recognize, oh, that's one of my formulas. I can go backwards and rewrite it like this. Huh? This is where they get a little more confusing. Okay? So, not too bad though. I like these ones. So, with this one here, this is how you do it. Alright? So, and I'm not going to do every single one of these because these are a little more time consuming. So for ones like this, what you have is you have two different angles, okay? You have sine of alpha is 4/5, and alpha is between pi over 2 and, let's say, put arrows on both. Okay, good. So where is this angle if it's between pi over 2 and pi? Which quadrant? Right, thank you, Molly. It's in the second quadrant. So you draw an angle over here. Alright? This is all one problem. Okay? So first I draw a picture for alpha. This is angle alpha right here. And its sine is, so you get the little thing. So it looks like this, okay? And its sine is 4 over 5. So then you do the Pythagorean theorem and you find this side. What's that side? Come on, you can do it. Negative, it's 3, but we call it negative because it's in the negative x direction. So here's your picture for alpha. And then what you do is you come and you draw a different picture for beta. Alright? So come over here. Yeah, a whole different picture for beta. Okay? So here's going to be your picture for beta. And which quadrant is this in if it's between pi and 3 pi over 2? Third quadrant. And then you draw a line going like this. then you say that the sine of this angle, it's a little more complicated, but it's -2, so you call this -2, and you call this root of 5, and then, what? It's all one problem, okay? Here's alpha, here's beta, right? Beta is between these two, so this is the angle beta, all right? And then what you do is you find this side using the Pythagorean theorem, so you have, hold on, root of 5 squared equals -2 squared plus b squared, okay? And root of 5 squared, hold on, Sam, I see your hand, let me just finish. 5 equals 4 plus b squared, so b squared equals 1, so b equals 1, except you call that -1 because it's working in the x negative direction. Answer these questions, okay? Cosine of alpha is -3 over 5. Yeah? You just look at the picture, right? Cosine of beta is -1 over root of 5, right? So it's -1 over root of 5, or yeah, negative root of 5 over 5, if you want to, which is equal to negative root of 5 over 5. And then if I want to do one of these, which you will, cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So what you do is you look at the different pictures and you plug those things in, okay? So we found that cosine alpha is -3/5, right there, good? Cosine beta is negative root of 5 over 5, right? Minus sine alpha, which they gave you, didn't they? Sine alpha? Sine alpha is 4/5, right? Or you can get it from the picture, 4 over 5. 4/5. And, yeah, that's right. Sine beta is -2 over root of 5, which they gave you up here, which is equal to -2 root of 5 over 5. Okay? And then what you got to do is simplify this. Okay? Negative times a negative makes a positive 3 root of 5. That whole thing over what? 5 times 5. 25. Minus times minus makes a plus. Plus 4 times 2 is 8 root of 5 over 25. Now at these, you can add square roots. It's like 3x and 8x, right? So this is equal to 13 root of 5 over 25. Okay? What?
No, you could do 13 regulars.
8? You got it. I'm not very good at addition. I'm good at straight. Okay?
So it's
11 root of 5 over 5.
4 over 5.
All right.
Minus 1 root of 5.
Your
So that makes it.
cities are